Here's a follow-up to the 4M square nuts. I just received my shipment of the 2mm high. So here's a picture of the 2mm high compared with the 3mm high. So you can get the point of the difference between them. One is flat on both sides and the other one has that raised bit that makes it just a bit too high to fit in the Michael Baddeley design files for some of the M4 nut placements. Others, it works, they work fine. So it's not that I can't use them. It's just that there's a lot of places that use just this size, and you'd have to warm these up and kind of melt them into the part to get them to work, and I didn't want to do that. So I ordered these off of Amazon, and they were about $7.19 for a pack of 50. I ordered 4 packs of 50. Again, I don't have Amazon Prime, but standard shipping is free if you have $25 or more in your order. So basically 4 packs of these together with tax put me over $25, so I saved about $7 and something cents in shipping, so I basically got a bag for free. What I wasn't expecting is when they arrived, 3 bags had about the same amount in them. This bag has about twice, so it looks like they gave me 3 bags of 50 and 1 bag of 100. So no complaints there, but now I have an extra 50 of those, so I have 250 of the 2mm high, and I've got this bag of 100 of these chrome-ish, silver chromed 3mm high, and then a bag of black anodized 3mm high. So I have got a ton of these square bolts now, or square nuts. So next thing, go over to, I actually started doing some assembly. These are the drive units. These are printed in PETG, which anything I print that's more than an hour and a half, 2 hours tends to get a warp to it. I am a little bit worried about this drive unit. This outer motor casing is the hardest part to print that I had in the whole droid. That's because it prints with this on the bed, and when I used supports, my supports in PETG were failing, so this is actually done with no supports. So it looks really terrible, but functionally it should be fine. But it warped from about here, all that kind of warped up a bit. And I'm a little bit worried about when it goes together, if that's going to cause a problem. That's, you might be able to see from the shadow that it's raised up a bit there. This one, not so bad. It's black, so it's hard to see shadows on that anyway, but that one doesn't really wobble. Whereas this one has a wobble because it's warped over here. So if I have to reprint this, I barely have any PETG left, so I think I would just print this big piece in PLA Plus. I'm printing it so thick that it should be okay, and I'm not going to be driving R2 all over the place, so I don't think it's going to have that much stress on it. So if this one fails, I'll just print one in PLA Plus. This one, 2 colors, obviously. Ran out of black and then did the rest in gray. It printed better. It's got some surface issues here. This isn't perfectly smooth down there. That last layer there didn't adhere very well. I don't know if that's because that was about the time where I changed from the black to the gray. Maybe that was why. But I think the gear in there should be fine. I don't think it's going to drag on anything in there. And I could just sand that a little bit too. But I don't think it's sticking up that it's going to be a problem. It's just a little bit rough. The instructions for this, a lot of the instructions are to use M4 18 millimeter long bolts. I got two kits that have multiple sizes of M4 bolts, and they go from 16 to 20. There's no 18. I went to my local Ace hardware store. They do not have 18 millimeter long M4 bolts, so that was kind of perplexing. So I have an option of either buying a bunch of 18 millimeter bolts, or what I did, I used 20 millimeter. 20 millimeter worked fine everywhere. They didn't bottom out, they tightened up everywhere so far. Obviously I haven't put the gears in the front panel on. The front panel will then have the same 20 millimeter going through all these different points to tighten everything down. But as of getting as far as I have, this is the only 2 points where you really want an 18 millimeter bolt. It is sticking out past the flush part of this plastic part right here. So the ankle goes in here with a pin of some sort to hold the ankle on here. There's I believe a printed pin, or you can use metal. My worry just is, apart from the fact that you'll be able to see that, if you're looking at the feet, you might be able to see that, is if the ankle, I haven't test fitted it in there, if the angle that the ankle sits at is too far back, it might scrape this nut, because again, it's sticking out past this smooth part of this piece right here. So I tried a 16 millimeter and it didn't get to the threads, and a 20, the threads came out. So what I'm going to do, probably at this point, because so far, like I said, these are the only 2 places that on each piece that really need an 18 millimeter. I'll probably take 25 millimeter bolts and Dremel the ends off to make them about 18. You know, it may be not the best way to do it, but I've cut bolts before, and I'd rather, you know, just safety glasses, a rotary tool, and some vice grips. I'd rather do that than spend the money on a whole bunch of 18 millimeter bolts if I don't actually need more than 4. If I need like 10, if I find putting the front piece on that I need a whole bunch more, then I'll probably order some. But right now, as I said, it's easier to see on the black piece here. These are all 20 millimeter. These are held in to this piece. I forget the length. There's a bolt here, here, and here. These 2 call for 18, and I use 20, and they're fine. They're recessed up in there. They didn't bottom out, and they don't stick out. These 2 were smaller. I can't remember what they are right now. I want to say 12 millimeter, but I had those in my kit, so those were the right bolts. So these 2, and then all the ones you see on the back, 1, 2, 3, 4, 5, 6 at this point, are all 20 millimeter, with these 2 that should not be 20 millimeter. Other thing I wanted to show, which again might be easier on the white one. In here, I've used the square nuts that are 3 millimeters high. And the reason I did that is because these don't have the nuts sliding in. right? Like this. Let's see if I reach over here and grab one of these. So in my hand is one of those 3mm wide, and it will not fit in that slot. Well, actually, I've got a 2mm in there and a little bit of glue, so it wouldn't fit in there anyway. But the 2mm just drop right in, just absolutely easily drop in. I just use a really small screwdriver to push them all the way down, because sometimes there's a little bit of filament from printing the parts that just gets in the way of the nut seating all the way down. So the instructions, the glue is one of the things it tells you to do, is put the nuts in there and then put just a little bit of hot glue in the slot, so that if you're working on it, the nuts don't come out. Otherwise, you work on it this way and a nut will fall out that's up over here. This one here, captured nut, that one might fall out, and this way, you know, the other two might fall out, and there's one up in here. And so, yeah, what I did, these three, and the three on the other side. This piece has three, but you can't see them because this back plate covers it. The 6 that hold these 2 pieces on, I didn't put glue to hold them in, but all the other ones I did. And the way I did it was, I got the nut all the way down in the hole, and then with the hot glue gun, I just kind of squirted a little in the corner. Just kind of made sure it was coming out, and then just kind of moved the glue gun away. So basically, I'm not filling that entire cavity with glue so that the square nut is, you know, trapped in that one position. I'm trying to just let the square nut kind of sit in the hollow, and then just put a little bit of glue across one or two of the top corners, just enough that the nut won't fall out if you turn it upside down, but not in there so much that if, when you do the glue, you go to screw the nut in, and you find that you've hot glued that square nut too high, and so you can't get your bolt threaded into it. So the other way to do it is to go ahead and put a bolt in, thread it in, and then do the hot glue, and that way you know that you've got the hot glue holding that nut in place at the right position for a bolt to go into it. So there's a couple different ways you can do it. So that's about it for the drive units. I have the tire and wheel that I showed before done. I've got bearings for both the left and right side for that. I have the center gear here, but the bearings I don't have yet. Those should be here. It's currently a Monday. They should be here by Wednesday. I don't have motors. That's the big thing right now. Gone a little bit overboard with purchases here this past month on this project. So I'm thinking I might just go ahead and get everything assembled with no motor. So there'll still be the tire, the omni wheel, and the center gear, and they'll all be held in place. I think, yeah, because there's a plastic pin that comes up through here and holds that center gear in place. So nothing will be loose or fall out. It's just that when I get a motor, I need to put the gear on the end of the motor and then slide the motors into the drive units. But I might get them all the way complete apart from that, just so I can double check that everything works, everything fits, and things roll. And then the motors can literally come months down the line when I get to the electronics. I have lots of time to think about that. So, but I really wanted to get some actual mechanical assembly done, as all I've done is glued. I printed everything, but I've only glued some pieces together. I haven't done any major assemblies, so these are the first major assemblies that I did. So, putting those aside, speaking of major assemblies, this is the Mark III center foot with the modification to use Vex Robotics Omni wheels. It's a big mouthful, but basically what you can see is this rolls in any direction. Not just front and back, it goes side to side, any direction. It's got wheels on the ground. This filament happens to be some that I got when I bought one of my printers. It's a Xyltech, like a translucent red. I've saved over $100 on my project by using up filament that I got with that printer and some PETG that I bought for half price off someone on Craigslist. The PETG that's the black, gray, and some of the white. So this is how it would be assembled, and then this hole here is where the center ankle goes, and again there's a 3D printed pin that you can put in there for the ankle to pivot on, or some people use, I believe, an 8mm threaded rod or 8mm solid rod to go through these pieces and through the ankle, because that's a lot stronger than a printed piece. So if we take this assembly apart, there's three parts. This part here, I'm going to call one part. I haven't put the nuts in or the bolts, so it's actually three parts. I printed it in PETG. And what it does is it goes okay. It was a little bit confusing trying to figure out how that went together, just because I hadn't built it. I was just looking online and how everything goes together, because you now cannot put this foot shell on. So the way it has to go together is this piece has to go inside the foot shell first, which is made to, hold it in place. And then you need to, see if I can do it without having that fall out. Turn the foot shell upside down. Then you need to take your wheel assembly, whether you're doing the modification to use the purchased Vex wheels or the 3D printed Omni wheels, either way, you end up with this piece that you have to bolt into that piece. So that's got 4 holes, that's got 4 holes. There's the square nuts go into slots in this piece on the other side. So the bolts come up through here and down into there, like that. And if you notice, at least with the Vex Robotics one, well, you might be able to, I didn't think that you could actually tighten those, get those in there with the wheels in place, but it looks like you might actually be able to. Huh, that's interesting. It's the first time I actually held it up to a light like that. I just finished this like 15 minutes ago and got excited, so made my first Monday video. Monday I usually don't do much of anything. Working weekend graveyard shift. So yeah, it looks like you might be able to actually bolt that in without taking those wheels out. But if you do have to take the wheels out, it's not a big issue. The wheel assemblies are held in with 2 bolts on either side. So you take those 2 bolts out, and then these 2 bolts out, and loosen the nut, and then this whole assembly comes out. And the same thing, that assembly comes out. So then you would have just this frame, and you could put just that frame in there bolted in place, then drop these wheels assemblies back in and redo those 4 bolts, and now your whole assembly is back together again. So hopefully, there we go. So hopefully that makes sense. So basically the shell is kind of sandwiched in between this bracket where the ankle goes and then goes up into the leg, and the frame assembly inside that actually contains the wheels. And that's about how high off the ground it is. This Mark III foot shell, I think is a little bit different than the Mark II. I think that's one of the things that was made more matching the revised, what they call the, what is it, the CSR Club Spec Revised, as opposed to CSL Club Spec Legacy. Basically, they got, members of the club got a hold of a real R2D2 unit and made some measurements of parts that they had done their best guess from screen captures and photos. And they made some changes to, I think, all 3 feet, but I'm not positive. It might have just been the outer ones. But I do believe that the Mark III foot shells, all 3 are different. I think he made this one a bit bigger for some reason. Anyway, I won't go into that. That's irrelevant at this point, other than if you're going to print, I would print all the same. Because if you're printing the version 2 droid, you can use the Mark III drive units, shells, and mounting system. So I would recommend that, especially the drive units. The version 2 use a belt from the motor to the wheel to drive it, whereas this one uses herringbone gears, so there's no belts to break. So that's a much better design. So just be careful if you're doing a version 2 droid and you're using Mark III parts, because some of them interchange and some don't. So just make sure you read up on which ones you can interchange. I'm not going to sit here and say that the version 2 center foot shell will work with the Mark III wheel frame and ankle support here, because I can't say for sure. So make sure you research that if you're going to try and mix parts. But like I said, if you haven't even started printing or anything yet, even if you're going to do a version 2 droid because it fits on a smaller printer, I would recommend that you print the Mark III foot drives. You might have to find a split file for this center ankle. There are split files for the outer 2 feet, but I don't know about the center feet, if there's one that's split for smaller printers. Because I printed this on my 300 by 300 print bed printer. So it's this red is all just one single print. So it's something to check up on as well. But yeah, just really happy I got a few mechanical things worked on. Oh, one other thing. Just happened to be the way I put these wheels together. Nylock nut on this side here, and nylock nut over here, instead of them both being on the same side. You saw it fit in the shell and they didn't rub, so that wasn't an issue. The issue is, and it's good that I ended up putting them this way because it kind of makes it a little bit clearer. This is a 3/8 inch bolt. I think it's 4.5 inches long. You'll have to look at the modified file, which is on the OneDrive folder in the Michael Baddeley R2D2 Mark III plans. So that's just the head of the bolt that goes all the way through the wheels, and then it comes out the other side, and the instructions say a nylock nut is optional. Okay, so I got, I'll get a nylock nut. In fact, I actually looked at the difference in depth between a standard nut and the nylock, and it's pretty much the width of this area here, that's how much longer the nylock is. The problem that I only found out just a little bit ago when I put this on is that when you tighten it, the length of the bolt, 4.5-inch bolt, it doesn't even come up to the nylon. So if it's not coming up to the nylon, it's not really locking it in place. So I can tighten this some more, but already it's not exactly smooth. It only spins for a little bit, which is fine. It's not that's not like a problem. It's actually got 4 bearings in each wheel. There's a flanged bearing on both sides. Remember, this is one Omni wheel, one Vex Omni wheel. This is another, so there's 4 wheels. So there's a flanged bearing on both sides of each wheel. So 4 bearings this thing is rotating on, and this one too, with some spacers. There's Vex spacers between the 2 sets of wheels, and then there's a 5mm spacer in here, and then there's this piece here that bolts it to the frame, and then there's a metal washer, and then there's the nut. So I think what I'm going to do is I'm going to check my spare parts before I buy anything, because maybe I might have some nuts this size. So what I'm going to do is get rid of these, take off these nylon lock nuts, and get like a toothed washer, really thin toothed washer, and just a standard nut, and see if I can get it, I don't know, just see if that seems to make it work okay. Although, like I said, it's rolling fine, and it just depends on how much you tighten this. If I tighten this anymore, it won't. So that actually doesn't really matter if I put a different nut on it, because it's still going to need to be tightened to the point where the nut doesn't come off. But if I've got that thin kind of toothed washer in there to grab, then I shouldn't have to tighten it as much as I have it tightened now, to try and get those threads to at least come up just so they're a little bit in the nylon, so it's not just finger loose. So this is I mean, if I really worked at it, I might be able to actually loosen that. So I'm a little worried if that's going to work itself loose. So I think with a tooth washer and a regular nut, that might be a better solution than a nylock. And again, that's just because the nylock nuts that I got, Ace Hardware, again, they're really thick. So you might be able to find 3/8-inch nylock nuts that aren't quite that thick, and you'd probably be fine. In fact, you might be fine without even using a lock washer and just using a standard nut. But that's my plan, is just to replace that with a standard nut and a toothed washer, just to see. I don't want it any tighter than this. That's tight enough. So yeah. And that was about my only issue with this. Bolts on this, again, the instructions for the modification for Vex wheels for the center wheel on the MK3 does not tell you what size bolts to use. So I ended up just trying 25mm, because I hadn't used any of those out of the little bolt kit that I got that has multiple bolt sizes. And 25mm works perfect. They go in, they tighten through the bolts, or through the nuts. They don't bottom out, so you can get them nice and tight. So they're not too big, they're not too small. 25mm, 4 on each side. This is a 4-piece frame. There's 2 of these side pieces. There's a top piece, and then there's a center piece. So the center piece has square nuts that these two bolts on either side hold that centerpiece in. And then these two bolts on either side piece hold the top plate in. And again, 25mm bolts, two on each side, hold the wheel assembly in. So if you unscrew that and loosen this nut a little bit, it all comes off with a nut, a metal washer, this piece of PETG, which I can't remember what it's called. I think it's the bolt holder. Then there's a 5mm round spacer that you print. Then a flanged bearing, omni wheel, flanged bearing. In between there's a spacer from Vex Robotics that I can't remember what it's called, but it's a spacer that goes in there to keep this wheel and this wheel from rubbing together at all. Without it, if you put these together with these, I guess these would be touching. So there's one of those in here. And then there's also a 4mm round printed spacer also in there. Another flanged bearing, another flanged bearing, another 5mm spacer, the bolt holder piece, metal washer, and then this is the 3/8 inch, believe it's 4.5 inch long bolt. And these are both the same assembly, so that's just duplicate over here. So yeah, really happy with that. Spins great. I mean, again, it doesn't roll forever when you're spinning it by hand, which I kind of wish it was a little bit smoother there, but with all those bearings in play, I think it's fine. I don't think there's any kind of problem with it. So that's your center foot. And these are your outer feet, partially done. So there we go, Monday video, some actual progress on mechanical assembly.